Good day, we're Group 4, and today we will be discussing logistic regression. What is logistic regression? Logistic regression is a type of statistical model, also known as logit model. It is often seen and utilized in classification and predictive analysis. It measures or estimates the mathematical probability of an event occurring given a dataset of independent variables. It is considered to be extensively used in predictive modeling and commonly used in binary classification problems. There are three types of logistic regression models, which are defined based on categorical response. The three types of logistic regression is binary, multinomial, and ordinal. The first type is binary logistic regression. It is a statistical method used for predicting the probability or likelihood of an event occurring when the outcome variable is binary, meaning it has only two distinct classes or categories. The two possible outcomes are typically coded as 0 and 1. Here's how binary regression works. Imagine you have a pet hamster named Fluffy, and you want to predict whether Fluffy will wake up early in the morning or sleep in late. You start by keeping track of whether Fluffy wakes up early or sleeps in late each morning, along with factors like the weather. This process is called data collection since you gather information. Then, you represent each morning as a data point, noting whether Fluffy woke up early, coded as 1, or slept in late, coded as 0, and any relevant factors like the weather. After gathering the data, you use it to train the binary regression model, which learns how factors like the weather relate to Fluffy's wake-up time. Once the model is trained, you can give it new information about the weather in the morning, and it will predict whether Fluffy is likely to wake up early, 1, or sleep in late, 0, based on that. So, in simple terms, binary regression helps us predict whether an event, like Fluffy waking up early or sleeping in late, is likely to happen based on certain factors like the weather. The second type is multinomial logistic regression. It predicts the probabilities of the different possible outcomes of a categorically distributed dependent variable, given a set of independent variables. It is used when the outcome variable is nominal and the categories cannot be meaningfully ordered. Multinomial logistic regression is a generalization of logistic regression that deals with dependent variables with more than two categories. These categories do not have a natural order, making it suitable for classifying instances into multiple classes. It extends binary logistic regression to handle multiple classes without a natural ordering. Performance can be assessed by measures like confusion matrix and classification accuracy.
So here's how multinomial regression works. Let's imagine you have a class of students and you want to predict what kind of snack they will choose at a party based on two things: their favorite color and their favorite animal. The snacks they can choose from are apples, banana, and carrots. Now, you then ask the students what their favorite color and favorite animal are, and what snack they prefer. This process is called data collection since you gather the information. Now, after gathering these, you represent each student's favorite color, favorite animal, and snack choice as data points. For example, student's 1 favorite color is blue, and his favorite animal is a cat, and his snack choice is an apple. And for student 2, her favorite color is red, and her favorite animal is dog, and her snack choice is banana. And then for student 3, his favorite color is green, his favorite animal is a cat, and his snack choice is a carrot, and so on and so forth if you have more students. The data representation above will be utilized to train the multinomial regression model. The model learns how favorite color and favorite animal relate to snack choice. Once the model is trained, you can give it new information about a student's favorite color and favorite animal, and it will predict which snack they are likely to choose. For example, if a new student says their favorite color is blue and their favorite animal is cat, the model might predict that they will choose an apple as their snack. So, in simple terms, multinomial regression helps us understand how different factors like favorite color and favorite animal, relate to predicting multiple outcomes, like which stack a student will choose.
The third type is ordinal logistic regression. It is a statistical model method that is used when there are three or more categories with a natural ordering to the levels. It enables us to determine which of our independent variables, if any, have a statistically significant effect on our dependent variable.
Here's how ordinal logistic regression works. Imagine you want to understand how much students enjoy a particular subject in school based on their study hours per week. You collect data from a group of students, asking them to rate their enjoyment level of the subject based on a scale from not at all to very much, and noting their weekly study hours. This process is called data collection. After gathering the data, you represent each student's enjoyment level and study hours as data points, the enjoyment level being your dependent variable and the weekly study hours being the independent variable. For instance, one student might rate their enjoyment level as moderate and study 4 hours per week. Using this data, you train the ordinal regression model, which learns how study hours relate to enjoyment level, considering the natural ordering of enjoyment levels. Once the model is trained, you can input new information about a student's study hours, and it will predict what is likely to be their enjoyment level of the subject. For example, if a student studies 6 hours per week, the model might predict that they will enjoy the subject at a moderate level. Thus, ordinal regression helps us understand the relationship between study hours and enjoyment levels, considering the natural order of enjoyment levels.
Alright, so now let's move on to the key concepts. Imagine you're trying to predict something that can only have two outcomes, like will it rain today, yes or no. Logistic regression is a tool that helps us do this kind of prediction using data we already have. Here's a breakdown of the key players involved. First, predictors, or things you consider. These are the pieces of information you think might influence the outcome. For example, for predicting rain, you might consider things like temperature, humidity, and cloud cover. In logistic regression, these are called independent variables. These can be numbers such as temperature or categories like cloudy or sunny. Next, target or the outcome. This is the yes or no question you're ultimately trying to answer. In our rain example, this is the rain or no rain. In logistic regression, this is called the dependent variable. Third, we have the sigmoid function or the squeezer. Logistic regression uses a special function called a sigmoid function. This function takes a number, a combination of the factors you considered, and squishes it between 0 and 1. Think of it like squeezing a balloon. No matter how much air you put in, it can only get so big. In our case, the squish number represents the probability of the outcome being yes. For example, a result of 0.8 might mean there's an 80% chance of rain. Last but not the least, coefficients, or weights. Each factor you consider, predictor or independent variable, gets assigned a weight. This weight reflects how much the influence that factor has on the outcome. A higher weight means a bigger influence on the probability. Imagine a seesaw. A heavier weight on one side will tilt it more. By looking at the weights, we can see which factors are most important in predicting the outcome.
As for the cases where logistics regression can be used, the first is analytics, where it can be utilized for making decisions or predicting based on the information given. It also helps with decision making, usually through binary classification, which is yes, no, true, or false, and it is useful for predictive analytics and statistical modeling. Then we have business, where you can use logistics regression in a wide range of tasks, from an operations perspective in predicting risks and opportunities to an advertising and marketing standpoint. We can also use logistics regression in healthcare, where it can be used in medical research to determine the probability of a patient having certain diseases based on factors such as symptom, family history, etc. Examples of where logistics regression can be used are in fraud detection for banks or businesses, where we can assess certain behavior, let's say credit score or other factors, to determine whether a transaction might be fraudulent. Another example is in medical research, where we can predict if someone has diabetes due to information that has been given, such as history, symptoms, lifestyle, etc. Lastly, an example of using logistics regression can be through marketing, where we can predict the likelihood of a consumer purchasing a certain product or service.
So, what's the importance of logistic regression? Firstly, is the loan approvals. Banks use the logistic regression to analyze their financial information, like income and credit history, to estimate how likely you are to repay a loan. This helps them decide whether to approve your loan application and at what interest rate. Think of it as a yes or no question. Will this person be a good borrower? Yes or no? Logistic regression helps the bank answer that question with more confidence. Another example is the medical care. Hospitals can use logistic regression to analyze patient data, like age, medical history, and test results. To estimate the risk of certain health problems, this information helps doctors make better decisions about patient care. For example, they might use it to predict a patient's risk of complications after surgery, allowing them to take extra precautions if needed. In short, logistic regression helps analyze data and predict the chances of things happening, especially when those things can only have two outcomes, yes or no. This helps people make informed decisions based on the information they have.
Good day everyone! Today we are going to learn how to code a binary logistic regression in Python. To start, we need to install first the required library, which is scikit-learn. Then we need to import the necessary library, which is from scikit-learn.linear_model. Import logistic regression. This is used for implementing logistic regression models. Next, we input our dataset. This list represents the weather. X represents the features or independent variables. In this case, it's the temperature and humidity respectively. An example we have here first in the list is a weather with a temperature of 20 and humidity of 70. On the other hand, Y represents the variable being predicted, rainy or not rainy.
Now, we create a logistic regression model. This is used for predicting the outcome of a categorical dependent variable based on one or more predictor variables. We then train the model using the fit method. We're essentially teaching the computer how to make predictions based on the provided data. Predict whether the weather is rainy or not. Let's predict a weather that has a temperature of 28 and humidity of 50. We then use our trained model to predict whether it's going to rain or not. Lastly, we're going to print the prediction. If the weather is rainy, it is represented by 1, and if not, 0.
Next, we'll delve into coding multinomial regression in Python. Similar to binary logistic regression, we begin by importing the necessary library logistic regression from scikit-learn, as this is used for implementing logistic regression models. Next, we are also going to input our database just like in the previous example. This list represents the weather. X represents the temperature and humidity. These features help us understand and predict the type of weather. On the other hand, Y represents the variable being predicted, which is the type of weather itself. For instance, it could be categorized as sunny, rainy, or cloudy based on the given temperature and humidity values.
Next, we create an instance of the logistic regression class. Specifying multi_class is assigned to multinomial to indicate that we are dealing with a problem where the target variable can have 3 or more possible outcomes. The solver assigned to LBFGS is an optimization algorithm that works well for smaller datasets. We then fit the model to our dataset using the fit method. Finally, we use a trained model to predict the weather type for a new observation with a temperature of 21 and humidity of 80. The predict method returns an array of predictions and we print the first element of this array to get the predicted weather type.
Lastly, we will be teaching you how to code an ordinal logistic regression in Python. First, we need to install the required library, which is mord. We can do this by running pip3 install mord in the terminal, and if you are a Windows user, write pip install mord. The mord library provides tools and models specifically tailored for handling ordinal regression tasks. It offers implementations of ordinal regression algorithms, including different methods for fitting ordinal regression models and evaluating their performance. Now, we import our necessary libraries. By importing Logistic IT, you can create instances of this class and use its methods to perform ordinal regression using logistic regression with the irrespective of dice approach. The label encoder class from the sklearn.preprocessing module in scikit-learn is used to convert categorical labels into numerical labels. Lastly, NumPy is a powerful library for numerical computing in Python. It provides support for large, multidimensional arrays, along with a collection of mathematical functions to operate on these arrays efficiently. Next, we are going to input our dataset. Similarly, X represents the temperature and humidity, while Y represents the severity of the weather. In this case, mild, moderate, and severe because, as mentioned, ordinal logistic regression is used when the outcome you are trying to predict is ordinal, meaning it has ordered categories. Now, we convert the target variable or the dependent variable, which is the y, to integers using label encoder. This is necessary because Logistic IT expects integer labels representing the ordinal severity levels. Then, we create an instance of the Logistic IT class. This instance serves as the foundation for training and making predictions in our ordinal regression analysis. We then train our model using the fit method. To predict the weather severity of a temperature of 17 and a humidity of 70, we use np.array as this ensures that the new weather data is correctly formatted as a NumPy array, which is expected by the predict method of the Logistic IT model. Then, we use our trained ordinal regression model to predict the severity of the new weather condition. Lastly, by running this code, we have an outcome of 0, which is mild.